Percentage yield is the amount of product collected from a reaction compared to the total theoretical mass. This example states that Jacob reacts hydrochloric acid and sodium to get sodium chloride. What is the percentage yield of sodium chloride if Jacob uses 10 grams of sodium and collects 10 grams of sodium chloride? The hydrochloric acid is not a limiting reactant. This means that the amount of hydrochloric acid used is always enough to allow all the sodium to react. We are given the atomic masses and formula masses of all products and reactants along with the reaction equation. As sodium has an atomic mass of 23, 1 mole of sodium weighs 23 grams. Jacob is reacting 10 grams however, so we divide the 10 grams he is using by the mass of 1 mole, which is 23, to work out the number of moles of sodium in 10 grams. We can see in the equation that 1 mole of sodium forms 1 mole of sodium chloride. This means that 0.435 moles of sodium will make 0.435 moles of sodium chloride. To find out the maximum theoretical mass of the sodium chloride we could make with 10 grams of sodium, we multiply the molar mass of sodium chloride and the number of moles. However, Jacob only collects 10 grams of sodium chloride, so we divide the 10 grams of sodium chloride collected by the maximum theoretical mass and then multiply the answer by 100 to get the percentage yield, which in this case is 39.3%. Atom economy is the measure of how many reactant atoms end up in the desired product. The equation for atom economy is the molar mass of the desired product divided by the sum of the molar mass of all reactants, multiplied by 100. In this example, Ashley wants to get as much sodium chloride as possible, which means the sodium chloride is the desired product. We are given the atomic masses and formula masses of all the reactants and products. As we can see, the formula mass of sodium chloride is 58.5, and the sum of the reactants' formula masses is 59.5. So what we want to do is divide 58.5 by 59.5 and then times the answer by 100. In this example, the resulting atom economy is 98.3%. This means that 98.3% of the atoms in the reactants end up in the desired product, meaning the reaction is very efficient. In titrations, you use a known volume of an acid, but it has an unknown concentration, and a known volume of alkali, where its concentration is also known, to find the unknown concentration of the acid. The acids and alkalis can be interchangeable. In this example, citric acid is being neutralized by sodium hydroxide. We are given the concentration and volume of the sodium hydroxide, however, we are given a table for the volume of citric acid. The example states that concordant results are those within 0.1 cm cubed of each other, meaning only titration 2, 4 and 5 are able to be used, as the others are anomalous. So, we work out the mean volume of citric acid by summing titration 2, 4 and 5's values, and then dividing the answer by 3. We then find out the number of moles of sodium hydroxide in the 0.025 decimeters cubed you are using by multiplying the concentration and volume of sodium hydroxide, which gives us 0.00255 moles. In the equation, you can see that 1 mole of citric acid neutralizes 3 moles of sodium hydroxide, and therefore we need to divide the 0.00255 by 3, which gives us 0.00085 moles. This is because 0.00085 moles of citric acid will neutralize 0.00255 moles of sodium hydroxide. We then rearrange the equation to get concentration equals the number of moles divided by the volume. Our answer needs to be in moles per decimeters cubed, so we need to convert the 12.13 centimeters cubed into decimeters cubed by dividing by 1000. We then divide the number of moles by the volume of acid, which gives us the concentration of the citric acid in moles per decimeters cubed. I hope this video helped you. If you liked the video, be sure to give it a thumbs up, and if you really liked the video and want to see more videos like this, be sure to hit subscribe.